Greetings, everyone. Welcome to Compound Inequalities. So you've just watched normal linear inequalities, or hopefully you've seen some in the past if you haven't watched that one. So now we're going to talk about compound inequalities. And basically the idea is that since inequalities can be entire sets of solutions, then putting different sets together just makes it compounded, right? I have more than one. Typically we have two of them, but you can actually extend this idea to any number that you wish. So the compound connectors are going to be ors and ands. And then we also have another type where the compound inequality is already merged. Okay, let's start with the first one, or. So what happens is you've got two separate inequalities. Now, for whatever reason, you've solved or done whatever it takes to get to this point. But the or is there, merging these two into one solid compound inequality. Okay? The or, you have to think about the way you would say it in English language. I would be happy if I got cake or ice cream, right? Or I would be okay at the movie theater if I saw this movie or that movie, right? With the word or, it's very relaxed. Each thing is individual. It's like uniting things together, okay? And that's where we're going to get this action here of union. That's an actual mathematical action that you can take to union two sets. You unite them. Basically, you just slamming them together, okay? So all of the pieces of both become one big monster set, okay? So that's what or does in a compound inequality. So I've got two different inequalities, right? Basically two intervals, and I'm going to mash these two together, okay? So you can do it the algebraic way, or you can do it the visual way, right? The geometric way. We're going to talk about both. The algebraic way is to think about all of the numbers that are less than 3 and all of the numbers that are less than 6, right? And then think about, well, if I could have both of those at the same time, and it doesn't matter which one, they're all good answers, what would it feel like if I merged them all together? You'd be like, oh, well, that's everything less than 6. Great. Or if you prefer, I've got what I call the 3-line combine, right? The 3-line combine is when I draw 3 lines. The first 2 lines are the individual inequalities, and the third one is the merging of the two with whatever compound connector you have, right? In this case, or. So you notice I've got x is less than 6, x is less than or equal to 3, and then I've got or, right? So x is less than 6, I've graphed. X is less than or equal to 3, notice the bracket because of the equal to. And then or just means mash them together. So as you can see, everywhere there's a shading, pretty much I'm just mashing these two together, and this is what I get. So I have the interval from negative infinity to 6 there, right? Of course, not including the 6, because neither one of the sets have 6. Okay, let's try another example. X is greater than 4, or x is less than 5, okay? Well, if you think about what numbers are either bigger than 4 or less than 5, okay? If you really think hard about it, you'd be like, well, I could practically pick any number. In fact, I could pick any number, and it would be true in either this one or this one, right? Any number in the world, right? 100. Well, 100 is bigger than 4. What about negative 100? Well, that's less than 5, right? With an or, as long as one of them's true, it's all good. So you would quickly, hopefully, realize that you actually have something that's representing the entire number system. Okay? The other way, of course, would be to do the 3-line combine. I draw my 3 lines. The top one is x is greater than 4. The bottom one is x is less than 5. And then the or means I'm just going to mash them together. So notice every number is accounted for because all I'm doing is combining these straight, number for number. So the whole line is accounted for, okay? So let's actually work an example over here from start to finish, okay? So what I'm going to do first is I'm going to approach the individual inequalities first, and worry about the or afterwards. Okay, so I'm going to solve here by subtracting 6 and dividing both sides by 3. So x is less than -2. Or here I'll subtract 5 to get rid of this. That's going to leave me with -3x is less than or equal to 0. Divide both sides by -3. Notice I'm dividing by a negative. So x is greater than or equal to 0. It does reverse the inequality, remember, because I'm dividing by a negative. So I'm down to where we were in the other examples, right? I have one inequality or another one. And so I'm going to do the 3-line combine here. I'm going to bring 3 lines out. And really, I just need some points of reference so that I can compare the two. Most of the time with these, since they're each donating a number, you can get away with the 2 marks on each one. If the numbers are fractions and decimals and a little bit more intricate, then you may want to put a few more numbers on there just to make sure your location's correct. But typically, since they're each donating and they have 2 of them, that's a good frame of reference here. Okay, so I've got -2 and I've got 0. And I want to graph x is less than -2 and x is greater than or equal to 0. And I want to use an or to merge them together into an answer. Okay, so let's graph them. Less means to the left of -2. So that's here. And I'll use a parentheses since it's not equal. Greater than means to the right of 0, and it has the equals. So I'll put a bracket and I'll shade to the right. Now remember, or is just uniting these. It's just going to bring them together in a union. Yeah? So then what's really happening is I've got some numbers here that will merge in, and I've got some numbers here that will merge in. So I'm really just getting this and this, like a set of wings. Okay? Well, those aren't one interval. Even though it's one merge, smash together answer set, they're not connected. So I can't call them an interval. I have to call them multiple intervals, which means when I write it in interval notation like I have already with these other ones, I'm going to have to write them separately and then use the actual union symbol. So then x is an element of -infinity all the way up to -2. That's this first interval. Union with bracket, right? 0 to infinity, like so. And then that would be my answer set. Next, we need to talk about and. Instead of or, and is also a connector, but it doesn't mean to just mash together. And, if you think to your English logic, means 2 things have to be okay to go at the same time. I want cake and ice cream, right? I want to go see this movie and this movie, which, you know, is kind of hard to do in real life anyway, but at the same time anyway. But you have to have that child mentality of, I want cake and ice cream or I won't be happy. That's the way and works in logic, okay? So we call it the intersection. It's only going to work where both things are meeting up and agreeing at the same time, okay? And I wrote the symbol for intersection here. You notice it's the upside down of the union. We don't typically have to write it that much with these, but you should know what the symbol looks like in case it comes up later with sets. Okay, so let's take a look at this one. X is greater than or equal to 5 and x is greater than or equal to 8. So I need to think of numbers that are both greater than 5 and greater than 8 and possibly equal to either one at the same time, right? So if I think to myself, is 5 greater than or equal to 5 and at the same time greater than or equal to 8? No, it's not. is 10 greater than 5 and greater than 8? Yes. So 10 would be part of the solution. So, you could piece it together like that. But let's do the 3-line combine, right? So I've got greater than or equal to 5, greater than or equal to 8 on the first 2 lines. And then this time, instead of just throwing them together, I'm looking for where they overlap, right? So notice they overlap here, which is the only place I've merged them. And therefore, I only get from 8 on up. And it is important to notice that the 8 is technically in both sets because this isn't equals. This does have the bracket on it. So when I merge them together, the 8 is also part of the solution set. And so I have from 8 to infinity as the total combined set here. Okay, let's look at the next one. Less than or equal to 4 or greater than or equal to 6 at the same time now because it's and. It has to be any number that can be both less than 4 and greater than 6 at the same time. If you think really hard about that, pick any number you want. You won't find any numbers that that's true for. I cannot be less left of 4, greater right of 6 at the same time. It just can't happen. It won't work on the number line. But let's do the 3-line combine, right? So I've got my 3 lines, less than 4, greater than 6. Both of them with the bracket, but notice there's no overlap. There's none to be united, not united, there's none to be intersected. There's no overlap. So therefore, the solution set is empty. Okay? So one way you could say is no solution, of course. But since we're actually talking about sets here, then we can finally use the symbol that everybody loves to throw around incorrectly. And that's the circle with the slash looking thing like that. Everybody likes to throw that out for no solution when a lot of times it doesn't actually mean that. It does, however, mean empty set. And that's perfect for what we're doing right now. We're talking about sets of solutions, and x is going to be a part of that empty set. There are no x values that this could generate. Okay? You may have noticed on the ors we had 3 examples. Here I've got 3 examples. I'm running you through all of the different little possibilities that you can run into. Notice here the overlap is because they're both pointing in the same direction, right? Here there's no overlap. I did the same thing with the ors, by the way. You notice there was just different types of situations that can happen. Let's do this last one and you'll see the most common and situation. So again, notice it's compound because I have the and, but I have 2 of them that I need to solve. Okay, so let's do that. I start by solving the individual ones. To get this one rolling, I am going to add 30 to get rid of this 30. Right? And then I'm also going to get my letters to the left by adding 3x to both sides to get rid of this one. Okay. So let's see, I've got 5x is less than 50 now. And I'm going to divide both sides by 5. 5 is a positive number, so it doesn't reverse the inequality. We're all good. And is still here sneaking around. There he is. Next, I'm going to subtract 14, because remember I want letters to the left. So that gives me negative 2x is less than or equal to negative 14. I'm going to divide both sides by negative 2. That's division by a negative. It's going to reverse this. X is greater than or equal to 7. All right? Let's do the 3-line combine here. Two points of reference, 7 and 10. Not too difficult to flesh out on that one. X is less than 10 for the first one, 7 and 10 here. X is greater than or equal to 7 for that one. And then, of course, I'll have my solution with and right there. All right. So less than 10. That's everything to the left of 10. Less is left. And then, of course, there's a parenthesis on the 10. Greater than 7 and equal. So bracket on the 7, shade to the right. Okay, now and. Remember, and is where I'm intersecting them. It's got to be overlapping. It has to be from both at the same time. And you'll notice there's a section here in the middle where that's completely true, where I can draw lines through both at the same time. So what's my solution? It's everything in between 7 and 10 here. Notice with the one with the bracket is actually in both, so I have a bracket. And then here, the 10 is in the bottom one, but technically the 10 is not in the top set there. So I have to parentheses that one because it's not in both. So then what is the solution set here? I have to say that x is an element of the set of numbers between 7 and 10, including 7. Okay. The last type of compound inequality is the kind that's already merged. And this is sort of an extension off of the and branch of this, but they're already merged. I don't have to do any 3-line combining or thinking about the sets. We're basically taking advantage of the fact that x can be one of those middle sections and the way that inequality symbols can agree with each other. So that's why it's actually important that you pay attention to the numbers and the inequality signs before you invest too deeply emotionally into one of these problems. Okay? First of all, if you remember how to read it correctly in your mind and out loud, then the thing will either make sense or it won't immediately for you, and you'll know whether it's good or bad. Okay? Now I know you've been trained to read most things left to right, but remember also, more importantly, we like to form our sentences with the subject then the predicate, right? So in the case of equations and inequalities, these are all sentences with verbs of being, which means the subject is just some object that is in a set or is a number or something like that. So x is always your subject. So when I'm reading this, I'm not going to go 5 is less than or equal to x is less than 8. Don't do that. Instead, you start from the middle because x is the subject. X is all of the numbers in between 5 and 8. Does that make sense? Sure. X can be the numbers in between 5 and 8. Then the only other thing you have to check is, do the inequality symbols agree with what you just read in your mind? Are they pointing in the same direction? That's important. The inequality symbols can never point differently. The alligators cannot eat each other, okay? And they can't point at each other either, okay? So don't ever have them pointing in different directions. If they're pointing in the same direction, you're good to go, okay? The other thing is you can do the cover-up method and just make sure that the inequality originally makes sense. Is 5 less than 8? Yes. So this one makes sense. And I would read it, x is all numbers between 5 and 8, including 5, because of the equal sign. And also the lovely thing about this is it's already merged, it's already ready to go as an interval. You can simply dump it into interval notation. Okay? So let's actually work one right here. The only difference with normal solving here is that you have 3 sides to consider instead of 2, because I have 2 separators here, 2 inequality symbols. So remember the golden rule. You can do whatever you want as long as you do it equally to all sides. Okay? So let's start by saying I only want my letter in the middle, right? That's how we want it. The letter should always be isolated in the middle of these. So I'm going to add 2. Right? Okay. So then I've got 12 is less than 3/4 x, less than or equal to 21. By the way, when we started this, did you double check? Did you look real quick? Is 10 less than 19? Are the symbols pointing in the same direction? Does it all make sense? Okay? Always remember to double check that. To finish this one up, I'm going to divide by 3/4. But remember, if I'm dividing by a fraction, I'm really multiplying by its reciprocal. Right? So these are going. That leaves me with an x in between. Here I've got 3 into 12 goes 4 times 4 is 16. And here 3 into 21 is 7, times 4 is 28. Okay, so then double check your answers. X is all numbers in between 16 and 28. 16 is less than 28, and it includes 28. All makes sense, good. Don't forget, you can actually write these in reverse, and that can happen if you divide by a negative. It tends to reverse your inequality symbols and stuff. It's not common to leave things this way, but as long as it makes sense, like 8 is greater than 5, sure. The one other mistake that can come from this, though, is when you convert it into interval notation. Interval notation has to be written in number line form, so beginning then ending, right? So you're not going to see interval notation in this order, even though this is technically correct. You can't write the interval notation that way. We don't have that problem here. I didn't divide by a negative. It didn't reverse anything. Just, keep it in mind it could happen. So let's finish this one up. X is an element of the set, starting at 16 but not including it, and ending at 28 but including it. Okay? Well, I hope this helps you finish up your understanding of inequalities by compounding them together.